Hello class, we're about to start Unit 3, Topic 9, Scientific Notation. Sometimes the answers we compute are either too big or too small to reasonably write out in standard decimal notation. This is why we have a shorthand scientific notation. Scientific notation, a number expressed in the form a times 10 to the k, where 1 is less than or equal to a, which is less than 10. And k is an integer. Notes, calculators use E to stand for times 10 to the power. The input key is EE for enter exponent. On the TI 8384 models, look on the comma key. Positive values of k correspond to very large numbers. Negative values of k correspond to very small numbers. Now we come down here to example 1. Write the number in standard decimal notation. We have 4.8 times 10 to the 7th power. Now whenever you multiply by 10 to a power or do the scientific notation, what you would do is you look at the exponent. If it's a positive exponent, you'll move the decimal to the right that many places. So since this is 10 to the 7th power, that would mean that we will move this decimal 7 places to the right, which would give us 4, 8, and then 6 zeros. And then this would be your final answer. So it'll be basically 48 million. Now we come here to B. We have negative 4.8 e to the 7, E7. Now this is how the calculator is set up. This is really this here. It's negative 4.8 times 10 to the 7th power. So that E7 means times 10 to the 7th power. So just like we did over here, we'll move the decimal 7 places to the right, but instead of a positive 48 million, this would be a negative 48 million. Now, we come here to C. We had 2.019 times 10 to the negative 3. Since when we had a positive exponent, we moved to the right. With the negative exponent, that means we will move to the left. So we need to move to the left 3 places. So it'll be 0.002019. Now here, this e to the negative 3, we know that this e to the negative 3 and this times 10 to the negative 3 is the same thing. So we'll move this decimal 3 places to the left, and this time the answer will be negative. So it'll be negative 0.002019. And that will be our final answer. Now we scroll down here to example 2. It says write the following quantities in scientific notation. So now we're going to do this backwards. It says the diameter of a human hair is about 0.00254 centimeters. So it's 254,000,000. Okay, so now we want to write that in scientific notation. So first of all, we know we can only have one digit in front of the decimal, and that digit must be greater than 1. I should have said greater than or equal to 1, but less than 10. And it must be one digit in front of that decimal. So we would need to move this decimal 3 places to the right. So we know we would have 2.54 after moving this decimal 3 places. Okay, now it'll be times 10 to some power. Now we have to determine the power. Now when we move that decimal to the right 3 places, the power is negative. Or when we move the decimal to the right, the power will be negative. So it'll be times 10 to the negative 3 power. Now we come here. In 2013, the U.S. government collected, it looked like this is $2,472 billion in taxes. Okay, so now we want to rewrite this in scientific notation. Now we know with this long number here, we're going to end up with 2.472. We don't have to write all the additional zeros. It'd be times 10. Now we have to determine the power of this exponent that we're going to have with the 10. Now with this number here, the decimal is at the end of this number. Now I know you didn't see the decimal, but it's at the end. And you've always known that decimals are at the end of numbers that do not have a decimal. And I'll give you a quick example, just like this here. We know this is the same thing as this. So the decimal is there, you just don't see it. So now we have our decimal here. We have to move that decimal 12 places to the left. Now remember, when we move the decimal to the right, the exponent was negative. Now that we're moving the decimal to the left, the exponent is positive. So it'll be times 10 to the 12. Okay, now we move on to the next page. Now on this next page, we talk about the keystrokes and everything that you have to do in the calculator. Now with that, we can further discuss these calculator instructions in class if you continue to have questions on this topic. But there are some exercises here we do need to answer. For example, example 3, it says translate the calculator outputs into scientific notation. The results shown below. We had 2 to the 8th times 100. And you notice that we had 25,600. So now they want us to write this out in scientific notation form that you would see in the calculator. And this is how it will go. It will go 2.56 because we know that we have to have our decimal here. And it'll be E because that stands for times 10. And we know we would move that decimal 4 places to the left. So it'd be E4. So it'd be 2.56 times E4. Now it says B. It says the results shown below. And remember, we're to translate the calculator outputs into scientific notation. And actually, this is already in scientific notation, so we don't have to do anything with this. Okay, now it says write the number in standard decimal notation. So we have example 4. So we want to write this in standard decimal notation. So since this is times 10 to the 7, that means we have to move this decimal 7 places to the right. So it'd be 6, 4, 7. Then we will have 5 zeros that will go behind it. So it ended up being 64,700,000. Now we go here to B. We had 9.2 e to the negative 3. We know that means 10 times 10 to the negative 3 power, which means we move the decimal 3 places to the left. So it'll be 0.0092. And that will be the final answer for B. Now we move on to the next page. We have example 5. In the case before the Supreme Court, the prosecution computes the probability of the defendant's DNA being an accidental match at 4.14496 e to the negative 16. Convert this to standard decimal notation. What does this imply about the case most likely? Now that means this means times 10 to the negative 16. Which means we have to move this decimal to the left 16 places. So in front of this 4, we will have 15 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, actually it's supposed to be 15, not 16. So 15 zeros. And then we will write down the numbers 4, 1, 4, 4, 9, 6. Now, they said, what does this imply about the case most likely? That is almost certainly a match. Okay, example 6. If you toss 5 fair 6-sided dice, as in the game Yahtzee, the probability that all 5 dice will come up 6 is 1.29 times 10 to the negative 4. This is called a Yahtzee in the game. State this in standard decimal notation. What might this suggest about someone who says they are going to roll a Yahtzee just before doing so? Okay, so we know that times 10 to the negative 4 means this decimal goes to the left 4 places. So it'll be 0.000129. Now, if the person say they're going to roll a Yahtzee, that would mean a person would be considered lucky. Okay, now we go to example 7. It says here, if we roll a fair 6-sided die 100 times and write down the results of each roll, how many possible outcomes are there for the entire experiment? Hint, use the multiplication rule of counting and exponents to do this quickly on your calculator. Okay, now, so let's think about this. Every time this person rolls, they have 6 chances of getting a number, because it's 6 numbers that they could possibly get. So if they're rolling at 100 times, that'd be basically 6 times itself 100 times, which would be 6 to the 100th power. Now, if you put this in your calculator will give you 6.533186.235 E77. And I'll show you here. This is what it would end up becoming on your calculator. Okay, now, our next step. We'll go down here to example 8. It says example 8, a royal flush, ace, king, queen, jack, 10, all in the same suit is the best hand possible in poker. The probability of a royal flush in 5-card draw poker is a very low number. Convert this to scientific notation. What would this imply about someone who gets 3 royal flushes in one game of poker? Okay, so if you notice, we have to move this decimal 1, 2, 3, 4, 5, 6 places. So it'd be 1.539 times 10, and it'd be to the negative 6 power. Now, the question is asked, what would this imply about someone who gets 3 royal flushes in one game of poker? Either they cheated, or are extremely lucky.